Welcome to the Technology and Systems of Automated Cars. This presentation is done by Robert Nickel, Sierra Scully, Hayden Spear, Michael Sestak, Allison Brady, and Jacob Collins. At the 1939 Futurama exhibit, Norman Belgettis created the first self-driving vehicle which was controlled via radio-controlled electromagnetic fields. These fields were generated via magnetic spikes embedded in roadways along which the car would drive. Though the computer camera technique was effective, in 1977 the vehicles were only able to travel under 20 miles per hour. So it still was not as effective as a manually driven vehicle. A decade after the Japanese released their concept with the computer system, the Germans released a vehicle through the VMORS, which could safely operate at speeds up to 56 miles per hour, which is 36 miles per hour faster than the Japanese original creation. At present day, there are many automated features in newer vehicles, from assisted parking to self-parking and braking. There are also a few here and there that can self-steer when on major roadways at constant speeds. They are able to do these things through the new GPS systems, lane departure detection systems, and the ability to detect obstacles. The autonomous cars being created now are some of the most technologically advanced creations the world has ever seen. Computers have always been in cars, from things like gear ratios, transmission efficiencies, but now we are seeing a whole new realm of innovative technology. In the 80s, the University of Michigan developed the ALV project, which showed the first road-following demonstration that used LiDAR, computer vision, and autonomous robotic control to direct a robotic vehicle at speeds of up to 19 miles an hour. That vehicle also demonstrated off-road maneuverability as it used sensors to navigate slopes, ravines, and other large rocks and vegetation. Autonomous cars and the relative IT information is very, very complicated. The modern autonomous cars use LiDAR, which is light years ahead of the original systems that had been developed in the 1980s. Among the many technologies which make autonomous vehicles possible is a combination of sensors and actuators, sophisticated algorithms, and powerful processors to execute software. The sensors and actuators in an autonomous vehicle fall into three broad categories. 1. Navigation and guidance, where you are, where you want to be, and how to get there. 2. Driving and safety, directing the vehicle, making sure it acts properly under all circumstances and follows the rules of the road. And 3. Performance, managing the car's basic internal systems. All of these technologies allow for the gathering and interpretation of the information available in a given environment. The car uses the information from these systems to make better decisions. Information technologies have been slowly improving since the earliest cars, but the core value of these improvements have changed drastically. What is fascinating about these revolutionary technologies at the time is that the inventions were adopted by other manufacturers and thus become today's standard. For example, in 1988, the first tire pressure monitoring system became available in Porsche's 959 supercar. While that seemed like an innovative and revolutionary technology at the time, today it has become standard in all modern cars. Information systems in today's cars. Convenience and entertainment information systems started to develop relatively early in automobile history. The appearance of these systems indicated the transition of the automobile from a vehicle purely for transportation to a lifestyle product. The information systems in today's automobiles are more high-tech than ever before. Features that are still impressive today, like internet radio, built-in driving camera, and GPS, are not just a feature of the hottest cars, but are now a required standard for all cars. One thing we do know for sure is that autonomous cars are inevitable. They will come, and they will become popular. With that being said, there will rightfully so be very advanced information systems to get these cars to function properly. Rumors are currently swirling about possible technologies such as cars without assistance from humans. This remarkable technology also brings up an ethical dilemma which will surely be discussed in the future, like the safety aspect. One important aspect is known as the layers of autonomy. This is the way that current innovative scientists that are creating these prototypes use to rate a car's capability on the road. There are 6 levels, starting with level 0 and going up to level 5. Level 0 means that all major systems are controlled by a human, and level 5 means that the car can fully operate on its own without any help from a human. As you can imagine, automated vehicles are going to be pretty expensive. Current estimates for the cost of hardware of these self-driving vehicles is between $70,000 to $150,000. The most expensive part of these vehicles is going to be the LiDAR. The LiDAR is a highly sensitive laser sensor that is the core of almost all autonomous vehicles. This gives the car a 360-degree field of view, and this alone costs about $85,000. There would likely be 4 smaller LiDAR devices elsewhere on the car. These would all cost about $8,000 each, and then add $32,000 more total. Radar is another $10,000 plus a few cameras for $6,000. For times when GPS is blocked, say by a tunnel, you'll need an inertial measurement unit, which is $4,000. Then there is a PC, a hard drive, a graphics card, and other hardware, adding another $5,000. This graphic shows the impact of autonomous vehicle technology and the cost structures of different operational models. First shown are the conventional private vehicles, also known as private car, and conventional taxi fleet vehicles without pooling, also known as independent taxi. Then presents the cost components for the case of conventional mid-sized vehicles in an urban setting with autonomous and without conventional vehicle automation. Because of the cost to manufacture these automated vehicles, it will take a lot of time before they are widely used. There are a lot of benefits to having automated vehicles in our world. First of all, they provide a better and cleaner environment. Automated vehicles are optimized for fuel consumption to be efficient and reduce CO2 emissions. These new age cars are expected to help reduce these CO2 emissions by 60%. AV technology can improve fuel economy, improving it by 4 to 10% by accelerating and decelerating more smoothly than a human driver. The second benefit is that they provide safer streets. Autonomous cars will reduce instances of accidents, with drunk driving distracted drivers, or driver errors, self-driving would remove the potential of these risks. Self-driving cars are projected to reduce traffic deaths by up to 90%, which would save 30,000 lives a year. The third benefit is that they prevent traffic jams. Every year, people living in American urban areas spend almost 7 billion hours in traffic, waste 3.1 billion gallons of fuel, and lose around $160 billion due to traffic congestion. Under normal circumstances, human drivers naturally create stop-and-go traffic, even without bottlenecks, lane changes, merges, or other disruptions. This phenomenon is known as the phantom traffic jam. University of Illinois researchers found that by controlling the pace of an autonomous car in the study, they were able to smooth out the traffic flow for all cars involved. Those aren't the only benefits to automated vehicles. Time is money. Average commute times in metropolitan areas in the United States are currently estimated to be around 27 minutes each way. With humans no longer involved in the driving, commuters are likely to save up to an hour every day, time that will undoubtedly have many spin-off benefits from well-being to boost the economy. More effective and affordable taxis. The Future of Driving report from Ohio University states that with autonomous taxis, the waiting time for a cab will come down from the average 5 minutes today to just 36 seconds. The cost of a ride, too, will come down to just about 50 cents per mile in a driverless car. More efficient parking. Automated vehicles remove commuters' demands for street and lot parking. Some cities devote a third of their land to parking, and automated vehicles could free up significant real estate for other uses, from parks to residences to office space. For personal AVs, commuters may be dropped at a location and the vehicle would park itself away from the destination where space is available. Cutting back on the land use for parking might even reduce real estate costs, according to a report from KPMG. There's also a significant amount of risk that goes into using an automated vehicle. Capability. Every capability of a self-driving car is programmed into a software. This means that if it has no buried wires, no smart speed limit, or turn lane signs, or special paint that would assist the vehicle in finding its way around. Since the roads can be unpredictable, this causes risk and can cause something to instantly happen that the car may not be able to react fast enough to. Weather. Self-driving cars may not be able to navigate through heavy rain or snowstorms that could hide or distort painted lines on the roads and highways. This can make autonomous navigation systems, if not useless, at least erratic. Security. Self-driving cars may give drivers a false sense of security. Drivers tend to become complacent with the technology that there is an increased reaction time of up to 17 seconds to a changed driving situation. On a regular car, it takes drivers less than 1 second to react to an unexpected event. Hacking and malfunctions. Self-driving cars can be hacked just as any other computing device. Any skilled hacker could soon figure out a way to take control of a vehicle's steering or acceleration. This can compromise the safety of the riders in a variety of ways. For example, hackers can take control of an autonomous vehicle, gain access to the car owner's personal information that could be sold, or most likely held for ransom by the attacker. There is also a possibility of terror attacks where the terrorist could gain control of an autonomous vehicle and use it as a weapon. Also, there is a chance that the system can malfunction or experience some unexpected glitch that causes the machine to act unpredictably or stop altogether. This can be dangerous when a self-driving car malfunctions while traveling at a high speed on the road. The future trends of automated cars. Where are we headed? Future business trends, future legal trends, future technological trends, and future usage and buying trends. Future business trends. For existing companies like Ford, Chevy, and Mercedes that already operate in a large part of the automotive industry, these would all have to attempt to stay competitive by investing in new technologies for autonomous vehicles. There would also be emergent companies. As the technology involved with automated cars becomes more attainable, expect there to be a shift in power from current car companies to tech companies. Tech companies will provide an integral programming for the automated cars, while traditional companies will improve current production methods to allow mass production of autonomous vehicles. At first, ensuring an automated vehicle is expected to become more and more difficult as the capabilities of the cars improve. This is because of issues with liability. If the car crashes, then the owner, the manufacturer, or the driver could each be held liable. Because of a rise in the usage and acceptance of autonomous vehicles, sociologists and scientists expect that they will eventually be used by the military and first responders to respond to emergencies. More countries will create ethical codes and guidelines for these automated vehicles. Currently, Germany is the only country to have an automated vehicle ethics code listing 20 guidelines that the industry must follow within the country. Future technological trends. Because automated cars are growing more and more capable of driving completely alone, drivers shift to become passengers. This would allow them to place their attention elsewhere. Many companies are expected to use this shift and focus to place advertisements within the vehicles. Without a need for regular windows, LED or LCD screens will become standard, allowing manufacturers to sell advertising space and force future customers to purchase some kind of ad block technology to keep advertisements out of their cars. Future usage and buying trends. Automated cars are expected to become cheaper as the technology becomes more widely available. Eventually, the cars will become cheap enough that families will be able to afford them if they want them. However, companies are expected to purchase vehicles en masse and run large taxi services. Families are expected to save at least $5,600 a year because large fleets of automated vehicles will be able for Uber-like services, so that people will no longer need to buy personal vehicles. This would result in less personal car sales and more bulk purchases by taxi-style companies.